Alright, so this video I'm going to show you how you can take a cross section of this part and so we can recreate it in CAD. So I'm going to be using Autodesk Inventor to do that, and then but it should be applicable to any CAD software. So let's get started. So the first thing I'm going to do is so I have to have my mesh already created. So this is my fusion, I just renamed it shaft. So the first thing you have to do is create some primitives. So what I'm going to do is create a cylinder, and I'm just going to highlight all of this, and I select it through. So now I'm going to create my cylinder. I'm going to go exact fit. Okay, so now what I'm going to do is create a plane, and I'm going to use a segment tool. There you go. That's all the information I'm using for my plane. Exact fit plane. Now I'm going to make my plane perpendicular to my cylinder axis. Okay, so you can see my plane is very thin, and the axis of my plane is now perpendicular, forced perpendicular to the axis of my cylinder, because I want that to be my center point. So next thing I'm going to do is align this to an origin plane. So I'm going to actually use my cylinder for my X, and now what I'm going to do is align my plane to my XY. There we go. And that's how I want to align it. So now what I'm going to do is go measure sections and volumes. See, I already had one here. I'm just going to delete that. Sections and volumes. And I'm going to use my construction plane. And the reason I'm doing it this way is because for Artec Studio 16, I'm not actually able to do a cross section on an origin plane. Hopefully that will change in the future, but this is my workaround to do that. So there we go. I click my plane, scroll down and go calculate. There we go. So I got my cross section that's straight through my XY plane that I created. So I'm going to save the section. I'm going to highlight my section here, and now this section I'm now going to export as a AutoCAD DXF. So I'm actually going to delete that one. There we go. So now I already have my Inventor open here, and now what I'm going to do is create a sketch. I'm just going to go XY plane. Now I'm going to bring in my AutoCAD file, or DXF file, into my sketch. Next, millimeter units. There we go, there's my cross section. I'm just going to do a quick dimension here to make sure, yeah, looks right. So because all these lines are not actually constrained, I'm going to highlight everything and lock them in place before I start working with it. Okay, so now they're all locked. You can see all my constraints there. Next thing I like to do I'll just shut off all my constraint symbols there. There we go. Next thing I like to do is just select all the lines and make them all construction lines. There we go. So now that they won't be selected once I create my revolve. So I'm only going to be doing the tapered portion, this portion here on the shaft, and then this little hub. So what I could do is I just kind of create some random lines, and it's going to be trying to constrain to certain things here. Do that. Just gonna make a random line across. That. There we go. Make that vertical. This one vertical. That one vertical. I'm gonna make all these horizontal. Now, next thing I'll do is just constrain somewhere in the middle there. Do a coincidence constraint. Same thing with this line. I pick somewhere in the middle of my that flat portion of the shaft because it becomes tapered after. And I'm going to do the same thing with this vertical constraint. There we go. And I'm just going to make this vertical constraint somewhere here. Next thing I'm going to do, I'm going to make this will be my center line right on the origin or the x-axis. I'm going to constrain this guy just somewhere here. Okay, so now what I'm going to do, oops, grab my line, drag it back a bit. I'm just going to extend this line. So it'll go right to, that should be close to where it starts to taper off. So now I'm going to create another line here. Coincidence constraint there. Now I'm just going to make this coincidence constraint somewhere here. There, so that looks pretty good. So I'm fully constrained there. You can see there's a chamfer here. You could model that in as well. Something like that. And I'm going to assume it's a 45-degree chamfer. That's pretty common for chamfers. It's just a quick way to deburr the sharp edges when you're turning. There we go. That looks pretty good. I'm just going to trim these lines. There we go. Now we're fully constrained. I'm going to finish. I'm going to revolve this. It already recognized because of my center line. There we go. There I got my the stub shaft. So next thing I'm going to do is just export this as a step file. I'm just going to call it shaft end. Now back into Artec Studio. I'm going to close out of this. I'm just going to shut off my primitives I created. Now I'm going to import the CAD model of my shaft end. So there, it imported the CAD model. So next thing what you can do, because we want to compare to see how well they compare with each other. I modeled my step file to the scan. So if you go to measure, distance map, we want to go from my mesh to my shaft end. So there's distance 1 millimeter, sure. So there you go. Now you can see all the deviation from my CAD model to my scan. So it looks like I'm a little undersized, but it looks pretty even. So it looks like my axis is very good for the end shaft. But you can actually see here, the center axis for this hub is actually not in line or coaxial with the stub shaft. You can see that because when I revolved it, the search distance is actually, it's out of 1 millimeter. So, don't know if that's an issue with this part or not, but there you go. That's how you can create a CAD model from your cross section and compare it to your scan data.